All right, I'm going to run through the answers to the review for you, or for the semester quiz. What is the weight of a 45 kilogram or 35 kilogram object? So remember that 35 kilograms is your mass. Weight is equal to mass times gravity is equal to 35 times gravity is 10. So this would be 350 newtons. So right here. Which of the diagrams below shows the correct use of the parallelogram rule? So parallelograms have sides that are parallel to one another. So that would be this one right here. So in this one, the two men are pulling. The key is that they are not moving. The one man is pulling this way with negative 490 newtons of force. That means the other man must be pulling that way with 490 newtons force. That is static equilibrium. A girl whose weight is 500 newtons is hanging from two strands vertically. Each one is supporting half of her weight. That means 250 newtons. What is the maximum resultant possible when you have a 2 Newton and 8 Newton force? And so 2 plus 8 is 10 newtons. And so 10 newtons would be the maximum possible resultant. The minimum would be 8 minus 2, which would be 6 newtons. You're helping your aunt move a piano. The key here is it's moving at constant speed and in a straight line. That means it is in dynamic equilibrium. So right here, dynamic equilibrium. 15 Newton force and a 45 Newton force act in opposite directions. That means you subtract 45 minus 15 is 30 newtons because they're opposing one another. For this one here, a 5 Newton force is applied to the cart in a northerly direction. Friction acts to oppose it with a 5 Newton force. Because those forces are balanced out, this is in equilibrium. The sum of the forces equals 0. So if it's moving at 2 meters per second, it will continue to move at 2 meters per second because there is no net force acting on it. This one here, there's a 5 Newton force this way. There is a 5 Newton force this way. This here will read 5 Newtons. Two forces are acting at 10 newtons. So we have 10 newtons here, 10 newtons here. It's asking what this resultant is. Well, if we use our parallelogram rule, then all sides are going to be 10 newtons. The diagonal is going to be our c. So in other words, c squared equals a squared plus b squared. So we have 10 squared plus 10 squared is going to be 100 plus 100. So we're going to take the square root of 200 and we'll get 14.14 on that. So 14.1 newtons would be your answer. So for this one, we want to know the x component. That is the red line here. So this is going to be our cosine function because it is the adjacent angle. And this is our hypotenuse, the 15 newtons. So we'd have the cosine of 28 is equal to the adjacent, which we don't know, over the hypotenuse of 15. We're going to rearrange this and we're going to say 15 times the cosine of 28. And if you do that out, 15 times the cosine of 28 is 13.2 newtons. So that would be this one right here. For this one down here, we're doing the exact same thing, except instead of cosine, we're going to use sine of 28 equals y over 15, which means we're going to have 15 times the sine of 28. And if you do that out, you get 7 newtons right here. For this one, we had to, so you're given the tension in each string, so 711 newtons here, 912 newtons here, and we want to know how much vertical pull the y here is from the red string and from the blue string. So once again, because that side is opposite of that angle, we are going to use our sine function. It's going to end up being 711 times the sine of 26. And for this side over here, it's going to end up being 912. And because, again, that's opposite, the sine of 38. And if you do this one, you'll get 561.5 newtons. And if you do this one, you'll get 311.7 newtons. They are both directed up, so we're going to add those two together. And if you add them together, you're going to get 873.2 newtons. So 873.2 newtons. Inertia is a resistance to change in motion. That's true. Change in velocity. That's true. Acceleration. That's true. So it is all of the above. Okay. Friction is a force that always acts to oppose motion, opposite an object's motion. The law of inertia states that an object that is not moving will never move unless a force acts on it. That's true. Will continue moving in a straight line unless an outside force acts on it. That's true. At rest will remain at rest unless acted upon by an outside force. That's true. Will continue moving at the same velocity unless an outside. So all of these are true. So all of them are correct. After a cannonball is fired into frictionless space, once it is set in motion, it will continue to move in the same direction, so no force is necessary to keep it moving because it's in a frictionless environment. Always true. Which of the following is always true? That an object following a straight line path at a constant speed must mean that's not always true. That's not always true. Has zero. That is always true. Has zero acceleration. Has no forces acting on it. That could be true, but it is not always true. Has a net force acting on it in the direction of motion. That is not true. It would not be in equilibrium in that case. An object has twice as much mass. If it has twice the mass, it has twice the inertia. Remember that inertia is mass. Compared to its mass on Earth, the mass on the moon would be the same. Mass does not change. It would have a different weight, but its mass would be the same. Oops. Rank the objects in order of least to most inertia. That is another way of saying the least mass to the most mass. So which one has the least mass? 10, 20, 5 is the least. Then, so it's going to go C, then D, then A, and then B. So C, D, A, B. For this one over here, object is accelerating. If an object is accelerating, there is a net force acting on it. This one, 20 and 20 cancel out. 25 and 25 cancel out. Nope. 15 and 20, there's a net force that way. So that one is correct. Cancel out. So that one's not right. Net force, so that one. Okay, so those two are both accelerating because there's a net force acting on them. So I already drew this one in. If you swing this around, if you let go at point B, it will continue moving in the tangential direction of what it was going. So as it's swinging around, it's coming in that direction. It will hit the target there. So that is at point B. I weigh 810 newtons here on Earth. What is my mass? So remember that weight is equal to mass times gravity. So if I want to know my mass, I'm going to divide both sides by gravity. So my weight of 810 divided by gravity of 10 is going to give 81 kilograms. A person is driving in a circle. So if they're driving in a circle, they're changing direction. If they're changing direction, then they are accelerating. Yes, they are changing direction. That is an acceleration. It takes a force to cause that. In a free fall problem with an object is dropped, you are given the acceleration of gravity, the initial speed, because if it's dropped, it's not moving. The final speed, no. The initial and no. Acceleration of gravity and initial speed, that's true. Initial and final speed and acceleration of gravity. So I'll have to go back and look and see if I just had this as the answer, or if I had you have to do all three. So this is the correct answer because these two are true, but I'll have to go back and look at that one for you. If an object is said to have traveled 45 meters to the east, so 45 is the magnitude, that says magnitude, and east is the direction. So that is a vector, which means displacement. Displacement is a vector quantity. A rock falls for 3 seconds, how far? So distance is equal to VIT plus 1/2 GT squared. Because it falls, it's dropped, basically the VI here is going to be 0. So it's going to be 1/2 G, which is 10, times the time squared. 9 times 10 is 90. Half of 90 is 45 meters. A car traveling at 25 meters per second comes to a stop in 4 seconds. What is the magnitude of the acceleration? Your acceleration is equal to your final velocity minus your initial velocity divided by time. It's only asking for the magnitude, so I don't care about the direction, but it would be 0 minus 25 divided by 4, and if you do that out, you get 6.25, so it rounds off to 6.3 meters per second squared. For this one, you're driving down the road, the car slams on the brakes, which of the following is true? The car accelerates in the negative direction. That is true. The car changes velocity. That is true. The car slows down. That is true. So the answer must be all of the above. It is stated that an object starts from rest. If the car starts from rest, it starts with 0 acceleration. That's not necessarily true. The car starts with 0 mass. Not true. Car starts with 0 velocity. That is true. How much time does a car with an acceleration of 5 meters per second take to go from 5 meters per second to 40 meters per second? Which equation would you use? So we're looking for time. We know acceleration. We know V initial, and we know V final. So we're looking for an equation that has all 4 of those letters in it, and it would be this right here, that your final velocity is your initial velocity plus acceleration times time. In the absence of air resistance, objects fall at a constant acceleration. They fall under the acceleration of gravity. What is the difference between a scalar and a vector? A vector has direction. So scalars involve weight, vectors include direction, and scalars do not. So there is your correct answer. If a freely falling object in the absence of air resistance were equipped with the speedometer, it would accelerate at 10 meters per second per second. So its speed would increase 10 meters per second every second. If an object has a negative acceleration and it's moving in the positive direction, that means it will be slowing down. And that was the last one. I know I went quickly, but hopefully you can go back and see any answers that you missed. And hopefully you can use this to help you if you need to take the retake.